This is the lecture number 2. This is regarding isentropic flow. So in aerodynamics and gas dynamics, frequently we have gone through the word which is known as isentropic flow. Okay, so what is isentropic flow? Which is the flow? We can say that it's an isentropic. Okay, what is the difference between isentropic flow or any other flow? We will know. Okay, in this lecture we will know. So isentropic flow. So we have two types of flow in our study, in our aerodynamics or gas dynamics. In entire 4 years of study, we will see the real flows and ideal flows. Okay, real flows, they exist in reality. Ideal flows, they do not exist in reality. Okay, in ideal flows we do not consider friction, viscosity or any kind of losses. Okay, in real flows we consider friction, viscosity and other losses. So suppose we have a jet engine and we are having the entire process. The air is coming to the diffuser and we are burning the gases, and hot gases are expanding into the nozzle. So in reality we have to consider that there is a real flow. There are some losses we will consider their viscosity, friction and other losses due to the flow operation. Okay, so ideal flow. So our main topic is the isentropic flow. Okay, so generally in any interview, whether we are going for DRDO interview or we are going to ISRO, HL or any kind of interview, they can ask that what is the isentropic flow, which flow we can say that it's an isentropic flow. Okay, so first off, it is an ideal flow. Okay, it do not exist in reality. It is a hypothetical concept. We study this for our practice, for to know the concept. We study this. Okay, so it is adiabatic plus reversible. Adiabatic means there is no heat transfer. Heat transfer is zero. Okay, negligible means if there is a system, okay, there is no heat transfer, means it is neither going inside or nor going outside. Okay, I hope you understand. Reversible means friction is negligible. We are not considering the friction due to the flow. Okay, we are not considering. So the main thing is isentropic is adiabatic plus reversible. Okay, this we have to keep into mind. And if we talk about entropy, whenever we are discussing any flow, whether it's real or ideal, okay, we have to especially in case of ideal isentropic flow, we have to consider or we have to talk about the entropy first. Okay, the symbol of entropy is S and change in entropy we say as del S. Okay, so suppose if we have real flow happening, or ideal, or isentropic flow. Okay, so here let me draw a jet engine. Okay, so this is the jet engine. So suppose we are getting the upstream flow inside the diffuser. Okay, here we have diffuser, then compressor, then combustion chamber, then turbine, then nozzle. Okay, so suppose the flow is happening. Here we are getting the fuel inside through the fuel injectors and all. Here the combustion process is happening. So whenever we are getting real flow, okay, in reality whatever we are doing operation, whatever we are doing experiments, in reality in our lab, in lab work, we will consider that the flow is real. Okay, that time the flow will not be isentropic, flow will be real. There will be friction, there will be viscosity, and the losses will be there. Okay, so in case of real flow, suppose this is the section 1, this is section 2. At the end, at the inlet, we are considering section 1, and the main thing is the flow is happening from section 1 to section 2. The entropy will increase. Okay, suppose here we have at section 1 we have entropy S1, some value, any kind of value we have, and at section 2 we got some value S2. Okay, so the entropy will not be same, will not be constant. S1 and S2 will differ. Okay, suppose here we have entropy 10 units. So if we have a real flow, entropy will increase, and here we will get 12 or 13. Okay, so basically entropy will increase. Okay, means I can say that entropy at section 2 will be greater than entropy at section 1. This is the one thing. Okay, then change in entropy means, what is change in entropy? Del S means S2 minus S1 will be positive value, means S2 is greater than S1, so automatically we will get positive value. So by summarizing, we can say that in case of real flow, entropy will increase between two sections. Okay, and change in entropy S2 minus S1 will be positive. Okay, let us talk about isentropic flow. We are just doing the comparison, okay, to understand what is isentropic flow, okay, and rest of the things. So in case of isentropic flow, suppose this is a jet engine or any kind of duct. We are having flow. Here we are entropy S1, here we are S2. So entropy will be same, S1 is equal to S2, and change in entropy S2 minus S1 will be 0. Okay, this is the difference. Entropy will not be increase or decrease, entropy will remain constant, and change in entropy will be 0 in case of ideal flow, which is isentropic flow. Okay, so by this lecture I have efficiently, I hope I have taught that what is isentropic flow, how it is different from other flows. Okay,